All right, class, I'm going to try this again. I've got a new piece of software and it's called a bamboo tablet. So I promised a video on problem three. Well, I'm going to do problem three, but with a different equation, okay? Because I want to see if you guys can repeat it. So instead of the equation being y equals 9 minus x squared, all right. Oh, this is the one I'm going to use, okay? But otherwise, the diagram on your handout still works. Okay. Because remember, that diagram is not to scale. So we have a rectangle that's inside of quadrant one of a graph, and we've got one on the positive y-axis, one on the positive x-axis, one in the origin, but the fourth point is on that graph. So it says express the area of a rectangle as a function of x. Well, so what do we know about the area of a triangle or rectangle? Gee, it's typically length times width. Except this time our length is x and our width is y. And they want me to make this a function of x. So to make this a function of x, that means I got to get rid of the y. So this is where the equation comes in. I can substitute that chunk for my y. I now have a function of x. Now, you can distribute the x through, but I'm going to kind of leave it for a reason. All right. But once I get rid of the y, I now have a function of x. That is the answer to A. Now, the domain. Typically, we'd look at this if we were looking at just the normal function. We would think all real numbers because it's not a radical, it's not a fraction. So we think all real numbers. But here, this is an implied domain because since we're talking area, I can't have a negative domain, can't have a negative area. So I know my domain starts at 0. Now, if I have an area of 0, that's not much of a rectangle. But how high does it go? Well, you set each of these to 0. So that's where the first piece comes from. X equals 0 and 25 minus x squared equals 0. And I'm going to solve. So I'm going to subtract off the 25. And then put negative x squared equals negative or positive 25, negative 25. Yeah, I was right. I divide by negative 1. So I end up with x squared equals 25. Now, when I square root it, I end up with x equals a plus and a minus 5. But the problem is, can I have a negative 5 for an area? The answer is no. So that part doesn't work. Only the plus does. So it's from 0 to 5. All right. So there's my domain. All right. And it asks us to graph to find the largest area. All right. So I'm going to graph that and look for my peak for y because, all right. So let me switch screens. I'm going to go to Desmos. Well, it's going to tell me I can't. If I shut that down, we'll lose what we have. So let me double check, make sure that's all I need. Yeah, the only thing I need now is to find the largest area and the largest x that causes that area. That's it. So I'm going to switch and I'm going to go to Desmos. And I'm opening Desmos right at the moment. Now my mouse is acting up. All right. So what was our equation? It was 25x minus x, not 2, minus x to the third. Or you can type the other in. All right. You know, it's showing you here from 0 to 5. And I want the maximum area. So I'm going to click on my graph. And right there it is. My largest x would be 2.89. That works. And my largest area be 48.1. All right. But this is problem 3 worked out. Okay. Now, you guys can repeat this using the y equals 9 minus x squared and see what you get. Okay? Good luck.